Today we're going to be doing notes 4.1 and 4.2. We're going to be doing matrix operations, so addition, subtraction, and multiplication. So the first key thing that you need to know is you can only add and subtract matrices when they are the exact same size, or in other words, dimensions. So looking at these two matrices, I can add them because they're the exact same size. They're both a 3 by 2 matrix, 3 rows, 2 columns. And how you add or subtract matrices is just by looking at the corresponding elements. So upper left, it's 4 plus -3, which would give me 1. And then likewise 8 plus 6, which would give me 14. And then 5 plus 4, which would give me 9. And then -1 plus 7, which would give me 6. 0 plus -2, which would give me -2. And 2 plus 1, which would give me 3. Okay, subtracting is the same. You just have to remember to subtract. So for this one here, looking at these, you can do it. It is legal. They are 2 by 2 matrices. So I would have 1 minus 8, which would be -7. And then 7 minus 2, which would be 5. And then I have -3 minus 1, which would be -4. And then 6 minus 4, which would be 2. All right, looking at the last example, I just want to show you here because I don't have corresponding entries. Notice this is a 3 by 2 and this is a 2 by 2. I can't subtract these because when I got to this last row here, I wouldn't have anything to subtract from. So this, you would say, if they don't match, you would write not possible because they're not the same size. So it's not possible. Okay, scalar multiplication is very, very straightforward. Okay, if I want to multiply a matrix by a constant, by a number, it just means I multiply every single element in that matrix by that said number. So if I wanted to multiply 2 by this matrix, I would just multiply every single element by 2. So that would be 8, that would still be 0, that would be -14, that would be -2, this would be 6, and this would be 4, and that's it. So scalar multiplication is pretty straightforward, pretty simple. However, when multiplying two matrices, so say, for example, A, which is an M by N matrix, times B, which we'll call a P by Q matrix, you have some restrictions, and here they are. So you look at the dimensions of the first and the dimensions of the second, and the middle, this right here, must match. If these numbers do not match, you cannot multiply those two matrices. All right, and what's real neat about this is these outer numbers here tell you the dimensions of the product of your answer. So let's go ahead and look at an example of this. So multiplying these two matrices, the first thing you want to check before you waste your time is it possible? This matrix here is a 2 by 3. Okay, so I'm going to write it out. 2 by 3 times this matrix here is a 3 rows by 1 column. So what I'm looking at again is, do these two numbers match? Ding, 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 yay, they do, check, so we're good. So these numbers here are going to tell you the size, the dimensions of my answer. So my answer will be a 2 by 1 matrix. Okay, so we know it's going to be a 2 row by 1 column matrix. The interesting thing about matrix multiplication is that it's very difficult, okay? Matrix multiplication, how you do it, I'll just show you real quick, is you take this times this, add it to this times this, add it to this times this, that's what goes here. Then you do this times this, add it to this times this, add it to this times this, and that's what goes here. So because it's very time consuming and, well, not exactly easy, kind of difficult, what we're going to utilize is the calculator. So I'm going to clear my calculator and I'm going to type alpha zoom. This is a 2 by 3 matrix. Okay, and it is 2, 1, 3, negative 8, 0, 4 times alpha zoom again. This is a 3 by 1 matrix. It is 2, 3, 6. Okay, so the answer is 25 and 8. So again, like I said, how they got that answer is 2 times 2, which is 4. So we'll just kind of write this off. Plus 3 times 1, which is 3. Plus 3 times 6, which is 18. So 4 plus 3 plus 18, does that equal 25? Why, yes, it does. And how they got 8 was this times this, plus this times this, plus this times this. That's what equals 8. So the calculator will do it for you, which is nice, but I do want you to also see where that comes from. Okay, so let's look at one more example for multiplication. Okay, so looking at this here, I've got a 2 by 3 matrix times, look, they're the same exact size, 2 by 3. And this is so weird. They're the same size. You want to be able to multiply them. Look at that. Those do not match. If those do not match x, you cannot. It's not possible. Okay? I know they're the same size, and I know that's so weird, but you cannot multiply them because that doesn't match. And I can kind of prove it to you because if I type this into the calculator, 2 by 3, okay, 9, 8, negative 2, 0, 6, 1, times alpha zoom, another 2 by 3. I've got, excuse me, you can't really see it, can you? 5, 2, 1, 0, 8, 6. Look what the calculator says, dimension mismatch. So the calculator knows it's not possible. It's going to give you error. Okay, so when you have something like this, the middle two don't match, your answer would be not possible.